All right. I'm up. Okay. So my name is Jack Douglas. I work for PacketStorm, and I chair the IPMX activity group along with Jean LaPierre from VIDTRANS. I'm going to talk about the activity group and what we've been working on here, and the implementation testing event and a Dirty Hands event that we actually held. So these are the associations that are associated with IPMX. You have AES, AIMS, AMWA, EBU, SEMPTE, the VSF, and this is all part of the JT&M Joint Task Force for Network Media. And so we all kind of work together on all these things as associated organizations. So as I mentioned, I chair the IPMX activity group along with John. This is for the Internet Protocol Media Experience, which is what IPMX is. And there's a series of 10 TR10 documents, as you've seen. So there's, at this point, 14 different documents that put together the IPMX group. And this is for the carriage of compression or uncompressed audio, video, and ancillary data for these documents. So these are the participating companies that you have here. So there are quite a few of them that are participating in these activity group calls and contributed to the documents. This is the status of all the documents right now. So there are 14 TR10s, and you can see the green, the ones that we're working on here. You can see the ones that were posted there. If you, let's see, I guess this has a pointer, right? Right here, right here. So this column is where we posted them up on the VSF website as drafts, and those are the ones that are currently posted up there. We had workshops, which you'll see here. I'm going to talk about those, what we tested during that. The latest one is this implementation testing event, which took place in the January timeframe in Munich. And then as a result of that, we had an outcome where we published these documents, and they are now showing as published on the VSF website. There are the activity group reports here for the switches. They have only been sent out for review. If anybody wants to take a look at that before we actually post them as drafts up there, please let me know. I'll be happy to send you a copy for you to take a look at. There are also 2 new dissectors that go with Wireshark that are associated with this, and this is also posted on the VSF website. So you could download those. Those have links to a GitHub, and the actual dissector is on the GitHub for it. Okay. So as you saw in Andy's slide earlier, there are a number of these now that are final based on this event that we had for the implementation event in Munich. So we tested to verify that at least 2 companies were able to work with each other and following the standard in the same way. And if there were any issues that we found, then we would maybe make a small change or something like that in the document to fix it, so that we made sure that all these were pre-tested and verified that they work. And so the first event that we had was this last year, and this was in March, and there were the companies you see there, 1, 2, 3, 4, 5, 6, 7, 8, about 8 companies or so that participated in this. This was at the NFL facility, and this was our first one and this was kind of a dirty hands event, right? So we were just fixing code and changing things, trying to make sure everything worked. It wasn't really fully testing to the standard, but just to make sure that we could interoperate and everybody understood what was being tested, what the standard meant. So here's the folks that were there. You can see what the facility looked like. It was in one of their large studios that was being not occupied at that time. And then we had this implementation testing event that I just talked about. And this was to validate the core documents of IPMX so that they can be published based on this testing event. So that is what we did, was test the core documents. The criteria for validation was at least 2 vendors operating with no critical or substantial issues. It was in Munich at the Matrox facility. It was January 20th to the 24th, and we had 8 companies here participating in this as well. You can see those companies that are listed there. This is what the event looked like. Lots of spaghetti cables all over there, right? We all just connected up and made it work. So we spent an entire week, very long days, getting this all running. And the results of that are we are able to release these documents, the TR 10-0, which tells you about all the organization of the documents, the -1, which is the timing of this, and the definitions of the document. And we actually spent a long time looking at this timing to make sure everything was the way we expected. So as it was mentioned earlier, the timing for IPMX is in the RTCP sender report. So we captured everybody's flows, and we looked at the time in the RTCP sender report, and then we looked at the time of the first packet of the frame, and that whole frame, as was mentioned earlier, would have the same time in it, and we needed to verify that that those times matched. And then we locked to PTP, right? And that time would now be with respect to PTP rather than just with respect to it running on its own, free running. And so we wanted to verify that that also matched the PTP time. So we looked at all those things and verified that it worked before we said that it was complete. So there were some small changes that took place there. It was mainly editorial associated with it there, and so we did an update to that document. The video document we tested with RGB, YUV with and without PTP. And there was a small update that we needed to do to that document there as well. With the audio, we validated both 16 and 24-bit at 1 millisecond and 0.125 milliseconds with and without PTP. We validated the HCAP as well. So we actually looked at the encryption as well as the whole handshaking of the HCAP to verify that that all worked. And then we did the TR8, which was the NMOS. So we used NMOS as the registries, ISO 4 and ISO 5 for the connection. So all the connections were made with NMOS, and everybody that was there was able to use the NMOS. And then the -11, which is the constant bitrate compressed video. This was JPEG XS, and this was RGB, YUV with PTP and with no PTP. So, to kind of answer the gentleman's question, Raul, I think it was here earlier, right? You were wanting to know, how do you verify that this stuff really interworks, right? So you can create a standard for codecs, but it may not work with vendor A and vendor B. So it was really part of this. We tested to verify that, in this case, we were using JPEG XS, that everybody worked with JPEG XS. The effort of the codec group is to look at, the values of different codecs of one versus the other, its attributes, what things are better about it, the latency, are there any artifacts that you get as you have different types of video with it? And if you go down and you look at the demo, you'll see that it shows the sequences, which are 15-second sequences that they will, test in an objective way to verify with it. So you would want to verify that the codecs are good along with the various metrics, but then you want to verify with it that it is compatible with each other at an interop of some type. And we are actually going to be testing those in an interop. I knew I'd bring up controversy. That's why I mentioned it. Go ahead.
I do codec testing for a living.
Yes. So does Ben, as I believe, who helped write this document.
No, Ben asked me to do his testing.
Okay.
When we do codec testing, we test thousands of parameters with millions of combinations, and the quality of video on a single codec varies enormously.
Right. And the way you measure it, whether it's subjective group and how, the size, all kinds, those make a difference as well.
We use SSIM, VMAP, other
Okay. All right. So, in any case, we will be testing with one type of compression between it. There will be different profiles. Right now, it's mainly JPEG XS that we tested. Okay. And the interop demo that we have downstairs, there are the vendors that you see here, the same 8 ones that were at the IPMX implementation testing event. We have everything displayed on a display that is a multi-viewer, thanks to Cobalt bringing that in. We have an Arista switch that we are using for this. It could have been a different kind, Netgear or something like that, but Arista was willing to provide us with a switch. We have NMOS that is using a conduct IP from Matrox. We have some HDMI outputs here that are feeding all these feeds for what you would see displayed on the multi-viewer here. And we have software and hardware senders and receivers that are all part of this. So it's all working down there. If you have questions about specific things, my booth is nearby. I'll be happy to come up and answer it. There are other people around that could answer those things for you as well. Okay. So what we're demonstrating here is a mixture, again, of hardware and software. We're demonstrating the published documents that I talked about, which are the -1, which would be the timing, the video codec, the video part of it, which is -2, the audio, the NMOS, and the constant bitrate video, which is JPEG XS. And these are the companies that are participating in that demonstration. Here's a picture of it. Please stop by. Please feel free to ask me any questions or anything. If you really want to see the RTCP sender report and that timing, I have a packet capture that I've done, and you can see it exactly in the packet capture and see how that works. So I could bring that up for you. And I think that's the end of my slides. Are there any questions?